Before there were stars, before there were galaxies, before there was space itself, there was nothing. And then, in a single, incomprehensible instant, everything that exists today burst into being from a point smaller than an atom. This is the story of the Big Bang, the birth of the universe, the beginning of time itself. Here is a question that has haunted scientists for centuries. What existed before the Big Bang? The honest answer is, we don't know, and here is why that answer is so strange. Time itself did not exist before the Big Bang. Space did not exist. The laws of physics did not exist. There was no before. The universe did not explode into empty space. It created space as it expanded. It created time as it began. Scientists describe the starting point as a singularity, a point of zero size, but infinite density and infinite temperature. All the matter, energy, and space that makes up our entire universe was compressed into something smaller than a grain of sand. Smaller, in fact, than a single atom. Approximately 13.8 billion years ago, that singularity began to expand. Not an explosion outward into space, but an expansion of space itself. In the first fraction of a second, the universe ballooned from something trillions of times smaller than an atom to the size of a city. The temperature was unimaginable, 18 billion trillion degrees Celsius, a heat so intense that matter as we know it could not yet exist. The universe consisted of pure, raw energy, nothing more. Then, within the first millionth of a second, something remarkable happened. That energy began converting into matter. Tiny subatomic particles, quarks and electrons, flickered into existence for the very first time. For every billion particles of antimatter that formed, there were 1,000,000,001 particles of matter. That tiny imbalance, just one extra particle in a billion, is the reason everything in the universe exists today, including you. In the first 3 minutes after the Big Bang, the universe cooled just enough for protons and neutrons to form. These particles began fusing together, creating the first atomic nuclei, hydrogen and helium, the two simplest elements in existence, the building blocks of everything that would follow. But the universe was still far too hot and chaotic for atoms to fully form. It was a dense, glowing fog, a sea of particles so thick that even light could not travel through it. For 379,000 years, the universe remained in this state, a brilliant, opaque wall of energy and matter. Then, as temperatures finally dropped enough, electrons attached themselves to nuclei, forming complete atoms for the very first time. In that moment, the fog lifted. Light, for the first time in the history of the universe, was free to travel. The universe became transparent, but the universe was still dark. No stars had yet ignited. No galaxies had yet formed. For hundreds of millions of years, the cosmos drifted in cold, silent darkness, a vast, expanding sea of hydrogen and helium gas. Then gravity began its patient work. Tiny ripples in the distribution of matter, differences so small they were barely measurable, began pulling gas clouds together. Over millions of years, those clouds compressed, heated up, and eventually ignited, becoming the very first stars, enormous, brilliant, and short-lived. These first stars burned hot and fast, and when they died, they exploded as supernovas, seeding the universe with heavier elements like carbon, oxygen, and iron, the raw ingredients of planets, the raw ingredients of life. At 500 million years after the Big Bang, the first galaxies began to form, enormous islands of billions of stars held together by gravity. Our own Milky Way galaxy formed around 1 billion years later. But how do we know any of this? The first clue came in 1929, when astronomer Edwin Hubble made a stunning discovery. Every galaxy in the universe is moving away from us, and the farther away a galaxy is, the faster it is receding. This told scientists something extraordinary. The universe is expanding, and if it is expanding now, then running time backwards, everything must have once been compressed into a single point. The second major clue came in 1965, almost by accident. Two radio engineers in New Jersey kept detecting a strange, faint hiss coming from every direction in the sky. No matter where they pointed their antenna, the signal was there. What they had discovered was the cosmic microwave background, the faded afterglow of the Big Bang itself, the oldest light in the universe, still echoing across space, 13.8 billion years after the beginning. Today, the universe is still expanding, and it is accelerating. Every second, the galaxies are moving farther apart. Scientists discovered in 1998 that something is pushing the universe apart faster and faster. They called this force dark energy. We cannot see it. We cannot measure it directly, but it makes up approximately 68% of everything in the universe. The universe we can actually see, all the stars, galaxies, planets, and matter, makes up less than 5% of what exists. The rest is dark energy and dark matter, forces and substances we have yet to understand. The universe is far stranger and far more vast than we can imagine. Here is something that should stop you in your tracks. Every atom in your body was forged inside a dying star. The calcium in your bones, the iron in your blood, the oxygen you are breathing right now. All of it was created in the heart of a star that exploded billions of years ago, scattering its contents across space, eventually finding its way into clouds of gas, into our solar system, into our planet, and into you. You are not just looking at the universe. You are the universe, looking at itself. The Big Bang was not a beginning in the ordinary sense. It was not an explosion in space. It was the creation of space. It was not an event in time. It was the creation of time. And out of that single, unimaginable moment, 13.8 billion years of history unfolded. Stars were born and died. Galaxies formed and collided. Planets cooled and hardened. Life emerged. And here we are, asking the very question that the universe has been building toward since the very first instant of its existence. How did all of this begin? The answer, as best as science can tell us, is with a bang.